anything in the class listing. If you want, you can add new data members or everything. Data members, if you add them, should be private. But in principle, you can stick with what is there in terms of interface. And you can see that we designed some names, type def, associate or name to an already defined type, as you know from C. Therefore, as you can see, iterator is nothing except a pointer to, but we call it iterator. We call it two parallel things. Constant iterator, as you can see, is a pointer T, which is constant. And then we have size type. There is size type in standard template library as well. This won't interfere with the size type in standard template library because it will be used always inside a vector. So, what is interesting to notice, this, as I mentioned before, is based in a way on the very simplified array templated class. Array templated. I gave you the code for array, how to write constructors and stuff like that, but it's a little bit more with more methods. First of all, there are 3 data members, and they are all private. The pointer, keeping track of how many current elements are in the vector, keeping track, allocate, of how many cells are allocated to the vector. So at the beginning, these are equal, but as you go on, you have probably, for efficiency reason, to change a little bit the number. And this is how the vector works. So be aware. You might start with, this is the number of elements, M size, and it's identical to M allocation, and let's say it's 3. And we store some values there, 8 minus 1, 9. And then we want to add a new element. Okay, assume that we have got at this stage, we created our vector variable V, which has these 3 members. If you know, these 3 members, V is like this. It has M data, M size, this is M data, M size, and M allocated. This is our vector. Now, I want to push an element on this vector. I don't have space. I am not guaranteed that the following space will be free for me to allocate. And this is what happened. Something else might have been stored here, another variable, an integer I, which was 7. It was stored there, so you can't rely on this location, and you need consecutive location. So what happens is, when I want to push back, we push back, or do some other thing, push back 9, 2, just not to do. I don't have space because my allocation was exhausted. We have to ask for new sequence of cells, and it's up to you how many sequences you want. Normally, the vector, the current vector does something. When the size is small, it adds double. When the size is larger, it doesn't double the location. It does add some 1/2 of the location or something like this. So what you can do is, for this assignment, allocate double space. The allocation was 3, now you ask the system to allocate you 6. 6, why? Because with 6 places you will have more efficient pushback. You can push back 3 elements here without reallocating. What does it mean reallocating? So I need to push 1 element. I set up MA to 6, double this value. Because I push this back, M size will be, first you copy from this one and then increment by 1, so you will have 4, and then you copy across 8 minus 1, 9, release the memory, reset the pointer, add 2. This is how things work in the vector, so be aware. Copy that function which is given there is quite useful because you can copy data across with that. Okay, so if I want to push back another element, what I have to do, I have enough space. My size is 4, allocation is 6, okay? Because of this, I know that I have where to put the next element which I want to push back. If I want to push back another element, I push back another element, and in this way, I have some buffer with no reallocation. Now, what happens when you remove elements? There are 2 ways to remove elements. One is efficient, but it doesn't preserve the order. The other one is inefficient, and the inefficient is what is asked there. Assume that you have this vector, and you want to remove, let's say, -1. What you have to do, you do not release the memory to the system. You are not interested in making the memory very efficient because at the moment, for what we need, we have enough space. And this is what the vector does. So what happened is, for the efficient way, which is not your approach, you look at the last element and copy it here. And this will be now the vector like this, and you say size is 3, M size. It doesn't matter what is here. Your user has to rely on the fact that this is meaningful data. And with this removing element is constant time. You take the last element and place in there, but it doesn't preserve the order, right? If we want to preserve the order, remember we had this. What we have to do is move this here, so 9 it's here, move 2 here, and now we preserve the order, we set up the size to 3. We don't care about this. Right. Okay. So, this is what you have to do with erase. And now, you have some private method, create an empty vector, create a vector with n elements and this value, g value, the value here, and copy this vector to the current vector. And these functions are given to you, and they are good model to have a look. How to do empty vector, how to do non-empty vector. And as you can see, P is a pointer to T, so P is an iterator. You can say instead of P pointer to T, you can say iterator. P is iterator type, because we have called it like that. Anyway, I think somewhere is used. And then here, how to copy this vector to the current vector is deep copying, as you can see, and you probably will use it. And here, you have to overload the output operator. You can use the type T, but Microsoft Visual C++ complains if you use the same type there. So a general approach is to have S, a different name. It's general. When you use T here, S is substituted by T. So when you use it in your example for integers like there, you in fact substituted S by int. So you practice with, and here you have an application of output operator overloading. So once again, if we go to the header file, you keep these functions unchanged, you don't need them, but you will have to look into your implementations, which should be all here. Method implementation should be not in line. So all methods should be implemented here. Constructors, everything. And when you write your constructor, for example, constructor for default constructor, here you probably will have just to invoke create. Nothing more. This is an empty vector. You will have to use this, for example, for erase. What does it mean to erase? Erase the element to which P points to. Shift each entry of the vector after the iterator. Return the iterator which will point to the same location. So this is erase using iterators. Z erase with pointers. I was thinking at clear. For clear, what does it mean to clear a vector? All you have to do is return an empty vector. That is clearing. Return an empty vector. So what happens is if I have this vector and I want to clear it, all I do is I return delete mdata and call create. And I end up with an empty vector. Create, which is this one.
Of the same size.
Sorry?
Of the same size.
Empty, clear means size 0. So if you get into size and stuff, look, create says empty vector. This is clearing. This is what clear means in general. So size allocation are there, 0. Right? You don't go and try to remove values from here. Nothing. It just returns this to the system, so you don't memory leak, and then call create. You end up with an empty vector with this. So this means clear. So try to read and see how you are going with working with this. You will notice that sometimes the system will say when you use vector size type, you have a vector and you have size type here somewhere. Sometimes you will use size type to do something. And the compiler will say, oh, it's not clear. Maybe you are using a type name. So all you have to do is put type name in front of vector size type. Because in this way, the type, the compiler knows that it's about a type. It's not a data member. It's not another issue. So if you get some errors, I will see.
When you have to return a size type with one of the functions.
Yes.
From the ages to work that out.
Yeah. You have to specify it's a type.
Yeah.
Size type, it's a type. So you return a value which is of that type. Where we have this. It's something like this. You have to return a value which is of size type. And then when you write out non-inline functions, sometimes you will get some things mentioned. Oh, I don't know what is that. I will give. Okay, so I would suggest you, when you start working on that, to comment out most of this testing and start small, for example, with this part, and then comment out everything else, and then add bits and pieces to your functions. So as you can see here, this is a way to use size type. It's something defined inside the vector. Here it's simple enough, but in some cases this is confusing for the compiler and requires you to say type name in front. We can put it here, but it's not necessary. And if you look at this, you see that you don't need for this part output operator overloading. We use some public data member. So for this, to test this part, you need just the constructor with 2 arguments, and maybe you want to use 1 argument as well, and size data member. And then you can an index operator overloaded. So constructor, size method, index operator, and then you can test everything up to here. So you implement just 3 methods, and then you are able to test this. And then you start adding things. If you want bits and pieces, and after adding 1 method, test it, and another method, test it. Otherwise, you might get into a little bit of a problem. It's not a big assignment, but it will take you through some interesting issues. Now, we have started talking about Java, and I mentioned you can run Java from inside Scite. All you have to do is, where is my file? I have put together some code from last lecture, Java program. Hello world. This is a type. This is a program, as it was on the slide. And if you look here at languages provided by Scite, you see that Java is one of them. Python, you can run Python and other things. So first thing is call compiler, compile. And if the system finds a compiler, Java compiler is invoked, and it's invoked on Java file. And as soon as the compiler does its job, you see the class file has appeared. As I said, this is not something you might want to read because it's not for you to read, it's for GVM, right? Java class. You can see file, Word, Java, something. Anyway, invoke the system, but it's not for us to look. And then all you have to do is run it like before, and the output is displayed in this part. So virtual machine, Java virtual machine is called on the class, and this is the output produced. And then for an example of arithmetic provided, notice that we use print line, string, and number, another string, another number. This is an integer division, an integer. This is true or false. Notice that this string can be concatenated with anything here because those types provide tools to allow concatenation. So, compile, the class is there, and then we have the output. Simple arithmetic. But what is important to notice, the integer division is integer. So if we want to do division and obtain the real number, we have to use a different operator. For Boolean, we have the result of this Boolean expression. This is first executed, second, and third, and the result is false. And as you can see here, we have the ternary operator in Java as well. So this is an example of simple operators used. Right. So this was, and you will, even if you have more files, more Java files, if you put them in the same directory, from all those files you will have one public class containing main, and then the system will, the Java virtual machine will create all classes and will start from main. You don't have to import anything from your design classes. This is what will happen. But we will see that. We will do it even simpler. Write everything in one class, in one file. Right, now let's try to move on and see the topic for today, which is Java variables. From Java's point of view, there are just two types of variables in Java, primitive and reference. Two types, they are huge groups. But be aware, everything is either a primitive type or a reference type. And there is a simple rule for primitive type, it's native type. Int, float, bool, everything else. And normally this type starts with lowercase letter. Lowercase, int, like in C++. Everything else is a reference type and should, in general, be used with new. And these reference types have names starting with capital letters. String, complex, and so on. But we will see that for some of the types coming from the language, there are some shortcuts. New is not always needed. Operators, and notice these two types. Arrays in Java are reference types. They come with this capital letter array, like strings, and should normally be used with new. Right, primitive type. Normal data types, as we know, and the reason for which Java is not considered pure object-oriented language, and object types. So primitive are declared on the local stack, like in C++, but objects are called reference variable, and they are declared using new. You will see that primitive types are always passed by value. You can't pass primitive types by reference in Java. It's not possible. So to swap two values, integer values, oh, you have to work very hard. If you want to swap integer A and integer B and preserve the swapping outside the function, is not possible because the function takes only these values by value. Copy works with copy. Everything which is passed of an object is passed by reference. Passed by reference. So be aware, strings, arrays are passed by reference. Functions, whatever change happens inside the function is preserved outside. In fact, they say everything is passed by value in Java. And this is true because when you pass an object, you pass the pointer value and you copy the pointer. In other words, the function copies this address so it works with the original object. So this means that everything in Java is passed by value. We copy the pointer. But this goes behind the scene, and you shouldn't rely on, try to distance yourself from using pointer. That Java does not support pointers as you know them. And we will see that Java references are not identical to the C++ references. It's a little bit confusing because we use this reference name and some other interfaces in two different, sometimes more than two different ways. So, scope of the variable depends on where it is declared. There are no possible global variables in Java. Everything has to be inside the class. So, if we have a variable declared outside all classes, you get an error. It's a common stylistic way to name your classes with capital letter, just to starting with capital letter. We will see that classes can be public, private, protected, like in C++, but we will work mostly with a public type classes. Like in C++, something declared inside a class is a data member and can be accessed by anything in the class. We will see what are the visibility rules in C++, a little bit different compared to visibility rules in Java compared to C++ are a little bit different. For example, here, if I don't put anything, it means that this data is visible in the whole package. This file stays in a directory, and we call the directory a package. So the default visibility power is the package. So outside the class, if we have more classes inside the same directory, they form namespace like in C++. But in Java it's called package. And this is how things are available. But for our point of view, we can say public float A, private float A, we will see protected float A. We can specify ourselves the visibility. Data members are initialized to data type default values. So integers to 0, float to 0.0, data members in a class. Local variables in a function are not initialized. They can have garbage value. But in Java, data members are initialized. So, B, a local variable in a method, as you can see, is not initialized. And if you try to print it, you get an error. So be aware of the difference. Local variable in method and member data. In Java they are called fields. Whatever is of class type, has to invoke new and the type followed by this, which tells us that the default constructor is called, or we can pass arguments. A custom constructor is called. So default constructor takes no arguments. Right, new and this. And this is why data members in the class have default values, because the default constructor sets the values for everything which is a data member. And then notice this notation we have for invoking method of the class, and you can invoke it with the same notation, data members, fields. If I have a field in the class, I can invoke it. Of course, whatever is public, normally constructors are public, and whatever is public is available in a class, is available to outside world. Right, new in C++ is associated to pointers. Be aware, here the pointers are hidden from us. We can't perform operations you are used to from C++. Why C++ references and Java references are different? Who shows you that they are different? We call objects defined with of non-primitive type, we call them references. So O1 is a reference. The new operator returns a reference object, which is assigned to O1. So be aware, new in C++ returns the address of the pointer where you point to some type. But in Java, new returns what is called a reference. So, as you can see here, we have one reference, another reference. Now we can reset O1. O1 is reset to point to something else. And here O2 is reset. And in C++ you can't reset references, but in Java you can. Okay? So be aware of this. And of course the syntax is totally different. In Java we don't have syntax with ampersand as we have in C++ for references. Garbage collection is another improvement in writing efficient code. Java system takes care of deallocating memory. Our job is to use new when we create objects, but we never use delete because there is no delete keyword in Java. The garbage collection does the job which delete, or the destructors we design were meant for. So the writer of the code is not responsible for memory management because this is done by what is called garbage collection. Yes?
So in the previous slide you changed the O1 reference to that first object.
This one,
Yeah, so the garbage collector.
the garbage collector returns the memory. It looks at whether the object is used or not. So as soon as we set up O1 to a different, the Java compiler knows that memory is free to be returned to the system. So the garbage collector does this. And I'm saying here, O2 was assigned this. Now when we use assignment, you will see, in fact, we have the same memory location. The assignment between reference variables like this work with memory location. So if this is O1 and this is O2, let's say point. As soon as I say O2 gets the value of O1, everything points here, this is returned to the system. They are. Okay, garbage collector, I mentioned this. Many numerical types, they are there for efficiency, and we have seen examples. I said that the default values for real numbers are double, and for integers are the large range. But we have unsigned and stuff like that. So we can perform output very simple using print line and concatenation. It's the only way in which Java does conversion behind the scenes. It's not quite conversion, but we will see how this is possible in terms of providing a single string argument to print line. No operator overloading, but function overloading is allowed, with one exception. For strings, we have a thing, concatenation. But in principle, if you design your own type complex like we have done before, you can't use plus operator to overload. You have to work only with functions. So operators plus symbols plus multiplication minus are not overloaded because it was considered confusing and error prone. So in order to perform the same operation, we have to invoke method. Add, multiply, and put the bracket. And this can become quite difficult to read and understand sometimes. But Java provides so many types that it's most unlikely to have the need to design some classes. Pass by value I talked about. C++ pass by reference is not available. Java references are passed by value because they work with addresses, they copy the address, so we have the same object, original object used inside the function. And here you have an example. You can see we have a class, and here we have a value, and we have the main function, and an auxiliary function which takes one primitive type variable, A, and one reference type variable, B. So we use a variable of this type. Okay? As you can see inside this function, we use copy by value. A here works with a copy of whatever we use when we invoke the function, a copy of I, a local copy. While B here uses the original object, C, which is this C. And then when we print data from inside, we get 5 and 6, because we are referring as a local variable. But when we print I and C, because this was passed by value, original I stays the same, 0, notice, while C, M value is changed, as we have seen, because of this passed by reference. Now strings are very versatile. We will see that one type is immutable. In other words, as soon as you declare a string variable with string, like this, string, you can use A equal new string, or you can use just hello, hello world. For strings, we can skip new. This is equivalent with A is new string. You can do it like this and pass hello W as well. They are equivalent. But if you want to change, they are sequence of characters, location 0, 1, 2, 3, 4. Assumes that you want to change A2, and you can access elements in string with index operator. If you want to do something like A2, change to, let's say, M, you are not allowed. You can't change individual elements in the string. And the reason is, you will see strings, for efficiency reason, when you declare a string hello W and you declare another string B equals with hello W, the same content, okay? You expect them to have different memory location, but the system, for efficiency reason, has only this hello space W. This is the location, and both A and B reference this. This is, once again, efficiency reasons. Strings are used extensively for small strings. With this notation, you get the same memory. So if you are allowed to change one value, because of this approach, the other B will be damaged kind of. There is a string buffer which can be used to change individual elements. Now, here, as you can see, what happens, as I said, for string, we have just this exception, concatenation. The concatenation is a method and returns a new string. So what happens here is hello is concatenated with this. The function returns the sequence, and that sequence with all characters is concatenated with this, returns a string which is set in this. So the location of string 2 is returned to the system after that, and string 2 gets this new string. So as a whole, it's not individual. And when you print it, you get the value. Similar thing, string 1 is updated with a new value. So each function, to upper or lower cases, they return whole strings which are set as a new value for the variables we use. Strings come with various methods. Length, concatenate, substring, split. They all return, as you can see, string, string, array of strings because you break a string in two. And index of gives you the location for first character. If you want to change individual elements, you have to work with string buffer. And for that, we have some other method. How you declare, for this we don't have any shortcut. So you declare simple string, and then you construct a string buffer from whatever predefined string you want, and then set character, what location, what is a new value. Very simple. And then you print the output, right? So this is a way to perform individual character changes. And Java arrays are implemented as objects. We use the notation like from C++, notice. A is an array of int. We don't use a class array, whatever is there. When you want to create these variables, you are required to use new. With this approach. So you can create an array of anything. Be aware we have null for a reference which is not set up to a specific value. It has, this is the equivalent of null pointer in C++. In Java it still is null. And the default values for references like string or other reference types is null. So if we create an array of strings, we have to set individual values, and then we can display them. There is a shortcut to this approach using using lists. As you can see from here, we don't use new. S2 has size taken from here, it's 4. A 4 array of strings. So both approaches are allowed. After you have declared this, trying to print string 0 will trigger an error because a null can't be printed out. Okay. So we can have double array, two-dimensional array, and what is interesting, they can have different sizes. But this won't be of much use to our, we won't work with double array, but they work like in C++. The important thing, as you can see, each array object knows its length, and length is a public field. Notice this is a field, it's not a method. Length is a field, so it's a public data member. And we have index operator to work with, so it's quite easy. The last slide. Everything which is not correct in Java is told to the user through exceptions. For example, if we have an array of 10 elements and we try to access something outside the bound, array index out of bound exception is triggered and it appears in red at runtime. Okay, so there are zillions of cases in which this appear. If the main function is not found and stuff. Library functions are there for copying array. We will talk about this. There are some requirements. We have to be careful because there is no public adjustment. But we will talk about this next time as we have to finish. So tomorrow we will continue with that and talk about input-output facilities. Thank you for coming and keep working on your assignment 2 please, because you will have a busy time probably in the coming weeks. Thank you very much for